Good morning, guys. Welcome back. So, I hope you're staying safe and sound at home. It's been a crazy time, to say the least, but we are all doing what we can, and just make sure you are, taking care of your health before anything else. So, anyways, I hope you guys are all doing well. Your families are okay. Your parents are okay. Grandparents. Um, and I'm wishing you all nothing but the best. So, today we're going to go ahead and move on to our very last section for chapter 11. It's 11.8. And this is going to be the last lesson that we do before we do a review game. So, I'm going to have you guys go ahead and go on joinpd.com and then enter the code here. It's NPOZE. Let's see. Okay. So it's going to ask how you're feeling today. Hopefully you're all feeling okay, you're feeling good. I'm going to go ahead and start the class. And so the very first one, actually, I wanted to go ahead and just do a moment of silence. So as you come in, this is more in class, obviously, you would find your seat quietly, take some deep breaths to calm your mind before we begin. Settle down, have your drink, your water, juice, whatever you want. And as you would come in and get settled, you would, answer what was your main takeaway from the homework. And obviously, this is a time for you to really think about the homework and how it was, how it felt for you. And this is something that I could get was okay, was easy, was hard. I learned a lot. Okay. So we're going to go ahead and move on to 11.8, surface areas and volumes of spheres. And our goal is to find the surface area of spheres and find the volumes of spheres. So here we're going to go ahead and take a look at a sphere, and then can you see any spheres in your room currently? Take a moment to explore your surroundings. I think so. The sphere is the most common one that we see in our daily lives. I think it is. Here's just some facts about it. It's perfectly symmetrical. All the points on the surface are at the same distance from the center. It has no edges or vertices. It has one surface. It's not a face, as it isn't flat. And so we're going to go ahead and explore this website. You're going to click on the play button and read a little bit about the largest volume for the smallest surface section. This is part of it, but I'm going to go ahead and it's going to look like this, and I'm going to have you guys click on this part. So let's go ahead and click on this. Let's see. Okay, so it's going to look like this. And so we're just going to go ahead and click on this part. So it's the largest volume for the smallest surface. You're going to go ahead and click on it, and you will see just how it blows up, right? And so what we see here is that of all the shapes, a sphere has the smallest surface area for a volume, or put in another way, it can contain the greatest volume for a fixed surface. For example, if you blow up the balloon, it naturally forms a sphere because it is trying to hold as much air as possible with as small a surface area as possible. So obviously, again, you could see that if you did click on the play button on the actual website, then you could see able to see that it blows um, it blows up, and then you can see how even though it seems like it is getting bigger, it's still the smallest surface area possible. So we're gonna go ahead and move on. And so now we're gonna go ahead and look at a glance at the surface area of a sphere formula. So carefully looking at the entire covering of the baseball, how many circles do you see? We have the circle. The area of a circle is obviously pi r squared. And so here, this forms about a general circle, right? And you see that we can do that here as well, and here and here. So technically we would have about 4 circles. So the area of the entire covering can be approximated by this. We have the surface area of a sphere equals 4 pi r squared, and that is just the general equation that we use, where r is, of course, the radius of the sphere. So we're going to look at an example here where the sphere has radius of 8 inches. You're going to go ahead and just plug that back in here. And again, you pretty much solve for everything except the pi. You leave the pi until the very end so that you can be as accurate as possible. You don't want to really estimate anything or round off anything. And then you're going to get 804.25 square inches. Again, because it is area, it's square. And then since we're talking about inches, then it's also going to be in inches. So here it's your opportunity to go ahead and solve this one. So now they're telling you that the circumference is 12 pi. So you know that the circumference is equal to 2 pi r. And so all you're going to do is just use that. So I'm going to give you guys like a minute or so to just go ahead and I want to see what it is that you are thinking. I'm going to go ahead and show the process here of what it would look like from my perspective looking at the student's work. Okay, so here I pretty much see what this person would be doing, and it shows me that they're thinking that the circumference is equal to 2 pi r, which they are right. Then they're going to go ahead and plug everything that they know, which they did. They plugged in the 12 pi for the circumference, and then they just solved for the radius. Then they use the surface area to go ahead and plug this guy in. So it's 4 pi r squared, and then all they're left with is 144 pi. So this would be perfectly acceptable, even if they didn't round it off. This is an exact answer. So I would have accepted this part. Okay. So then we move on, and let's see if you were on the right track. So here we're going to go ahead and just see if you were doing what I was doing, and so they're pretty much correct here. And then everything else, again, you're plugging it in until the very end, and that's when you would use the pi function again in your calculator. It would round it off for you as 452.39 square feet. Okay. So now, based on that, I would want you to go ahead and circle and let me know how it is that you're feeling, and then I can see what you are choosing. So now here you're going to be finding the diameter. So I'm going to give you a minute to just go ahead and just try and think about how you would solve this. This is more of a challenge. But again, it's just I want to see the process or the thinking process. I'm going to actually just wait a little bit. Okay, so I'm just going to go ahead and show their responses just to see what they're thinking, the process is like. So the surface area equals 4 pi r squared, correct. Then all they're doing, they're plugging this in here. And then obviously you would be solving for r, right? Whatever r is. And that would be, it gives me an idea of how they're thinking about this. Not necessarily, it doesn't really have to be the specific every single step that they're going through, but just me knowing what it is that they're thinking and how they are approaching this problem is just so much more helpful. So we're going to go ahead and just see if they were on the right track, which they were. In this case, we would have divided both sides by 4 pi. And then obviously at the very end is when we would go ahead and multiply by 4 times pi, and then you take the square root to solve for the radius. Now, the radius is 2.25. Something to remember is that the diameter is twice as much as the radius. So we would have to just multiply that by 2, and then we would end up with our diameter as 4.5 centimeters. So in essence, we're just working backwards. We were given the surface area, but now we were asked to find one of the parts. Not just the radius, but the diameter in particular. Okay. So now we're going to go ahead and find the surface area of this one. So it's another one to just get you thinking, get you out of your comfort zone here. It's not always going to be, the problems aren't always going to be looking exactly the same way, but it's just another way to think about a problem. Okay, so I'm going to show their responses just so that we can see what this person would be thinking about or is thinking about. Okay, so this is the surface area is 4 pi r squared. D equals 40. Therefore, the radius is equal to 20 because it's half of that. And now all that is left to do is pretty much plug everything back in there. So in this case, it's going to be 20 squared. And then obviously it would be 4 pi times 400. Whatever that, so that would be 1600 pi. So Let's see. Okay, so they were on the right track. The diameter, again, it's 40 in this case, but the radius is half of that, so you divide by 2. Since that's what we're going to be using here. And then everything else, you just, at the very end again, you pretty much plug this in here. So 1600 times pi, that will give you about 5,026.54 square feet. So now it's another dragging in to see how you're feeling after these problems. Okay, and then we're finally moving on to the volume of a sphere. Now the volume of a sphere is, it's a little bit harder to prove. It's a longer process than it was for the surface area of a sphere. So I'm just going to go ahead and give you guys the formula. So it's 4/3 pi r cubed. So finding the volume of a soccer ball with a radius of 4.5, all we're doing is just plugging that in here, and we are doing everything that we've done so far. So volume is 121.5 pi. You plug that into your calculator and you're going to round it off to 381.70 cubic inches. Now, because we're looking for the volume and not the surface area, we're now switching to cubic inches. So just one thing to keep in mind. Okay, so then think about the following statement. Whether you are talking about volume or surface area, the units are going to be the same. It doesn't really matter if you are using cubic or square units. So is this statement true or false? So at this point, students are going to be asked to choose an option. And I'm going to go ahead and see the results. And so they would say, okay, they chose true. So they are correct. Oh, I'm sorry. They chose true. They are actually not correct. It's false. You have to pay very close attention to whether you are being asked to find the surface area or the volume. So if you're being asked to find the surface area, keep that in mind. If it's area, it's square units. So it's either inches, feet, or whatever it is that you're talking about. If it is volume, you are dealing with 3 dimensions. So that's going to be cubic. So it is very important to pay close attention to these things. And then finally, we have our exit ticket, and this one is to explain the difference between a sphere and a hemisphere. This is kind of just thinking about not just the sphere itself, but the part, even within our own Earth, we have like the northern hemisphere and then the southern hemisphere. So just thinking about it like that, I would want to see how they are able to explain the differences between the sphere and the hemisphere. Okay. And then again, circle how you're feeling. Hopefully everybody is doing well. And that is pretty much it for today's lesson. So I hope you enjoyed it and you learned a little bit more.